Good morning. So as promised, we are getting ready to do questions 11 through, it's 11 through 50, but I don't know if we'll make it to all 50. We'll make it through as many as we can. Here we go. Earth and Space Science, June 2025 exam. Okay, question number 11 through 15. We're going to base our answers to the infographics below, the diagrams and the paragraph. They tell us about the carbon cycle, and they tell us that the carbon cycle recycles about every 3 to 5 years, and then that also plants recycle carbon every 50 years. Another thing they told us that was important is that the carbon cycle has two parts: the fast cycle that involves the process of photosynthesis and decomposition, and then we have the slow cycle that involves the time it takes for soil and organic carbon to form from weathering rocks and soil. All right, so then they give us this model of forest fires and burning fossil fuels on the carbon cycle. As you can see, the burning fossil fuels is going to cause some CO2 to go into our atmosphere and then be recycled back and forth. All right, so let's turn it over. And then we have another model also showing us the forest carbon and things that take place in the forest carbon. Okay, so the question says, explain the process that the trees in the forest uses to make energy for food, and describe how this process is responsible for a decrease in atmospheric carbon dioxide levels. Okay, so first we're looking for the process that's going to make food and energy for trees. So we all should know this process because they told us this in a paragraph, as well as we should know just based on our earth and space science knowledge. Okay, so what is the process that's going to be used for food and energy? Of course, that process will be photosynthesis, right? But how is this responsible for a decrease in the atmosphere? So how can we put this answer? How do photosynthesis, the take in of photosynthesis from trees, help decrease atmospheric oxygen? So all we're going to say is that these trees, or the trees that are growing, are going to take in carbon dioxide. So take in CO2, okay? And then what happens, or what we're going to say during photosynthesis, of course, because we don't want to miss the process. So during photosynthesis, okay, now what happens? Okay, so the carbon is going to get stored, right? We know that carbon is stored in the trees. So then during photosynthesis, and then carbon will be stored in the trees, okay, and the soil, because if you look in the diagram, it tells us that the ground carbon and roots in soil, so it stores about 50%. Then we also have a little bit more evidence over here that the trees are going to store some of that carbon, okay? So we should already know that our tree is a reservoir. So then once it's stored, then that's going to prevent it from entering the atmosphere. So I'm not going to finish writing, but it should say trees take in CO2 during photosynthesis. They store this carbon, and that is going to prevent the carbon from being released back into the atmosphere, okay? So since it's stored in the trees and in the soil, that's going to prevent, and it's going to decrease that atmospheric carbon dioxide levels. Okay, all right, number 12. Okay, so some more carbon dioxide talk, and then we have another cycle here showing us some numbers of the GT, or the gigatons, that is removed or added to the atmosphere per year. So the question says, which statement correctly identifies the quantitative cycling of carbon between two Earth spheres as a result of the natural process and human activities? So again, we're identifying the quantitative cycling, so the numbers, right, we're going to take a look at, between two Earth spheres, okay, in a natural process and human activities. So honestly, this is just one of those process of elimination questions. So let's just go through our answer choices really quickly. There is no other way to solve this, okay? So fossil carbon releases 23,000 GT, while microbial or microbial respiration and decomposition absorbs 60 GT. Is that what the diagram shows us? No, it does not, right? It tells us that fossil carbon releases 10,000, not 23,000, okay? 60G for the respiration and decomposition. Yes, that's correct, but the first part wasn't correct, so that's what makes number 1 wrong. Okay, number 2, the deep ocean stores 36,000 more GT than is released. So let's see that. So the deep ocean right here, so that says 37,000. This one said 36. So we're going to just say no, that can't be the answer either. All right, humans emissions add 9 times more carbon to the atmosphere than the plant respiration, which is the same amount as the microbial and the respiration and decomposition. So let's see if that is true. Human emissions. Okay, human emissions is right here. Okay, so this is how much is going to go back into the atmosphere, right? And then they told us compared to microbial, respiration, and decomposition. So as I can see, the plant respiration had 60% going back into the atmosphere, while human emissions only had 9. So if that's the case, human emissions did not add 9 times more than the atmosphere or the respiration and decomposition. So number 3 can't be it either. So we only have one other answer. Let's just make sure that is correct. All right, so the amount of carbon that leaves the atmosphere and is absorbed by the ocean is 92G, which is the same amount that's being released back into the atmosphere. So let's see if that's correct. So 92 right here is going back into the oceans, but then here we have this 2 that's being cycled up, and then 90 back into the atmosphere. So yes, that is correct. That is the same amount. All right. Question 13 says, which explanation describes how climate change and increased atmospheric carbon dioxide has influenced human activity? So how has the climate change from increased CO2, so we have all this CO2 in the atmosphere making it a little warmer, how has this influenced us as humans? Well, let's see. Have humans increased the replanting of trees in areas burned by wildfires in order to decrease the amount of local atmospheric carbon dioxide? Well, this could possibly be our answer. This sounds like a definite, right? Because if we replant trees, that's definitely going to decrease the amount of carbon dioxide, because that trees is going to store more carbon. Okay, number 2, humans have increased the burning of fossil fuels. Well, if we increase the burning of fossil fuels, we already know we are going to increase CO2. So that is not a good one. Number 3 says humans have moved to cooler climates. Have we really actually moved to cooler climates? No, we have not. Okay, we like warm climates and we like cool climates, but we adjust wherever it is that we move to, right? Okay, number 4, humans have decreased the number of dead trees in the forest by using them for fuel. Well, I don't think as humans it would be a smart idea for us to decrease the number of dead trees, right? We want to increase in order to decrease carbon dioxide. So, as we said, number 1 is the best choice. Humans have increased the replanting of trees. All right. 14. All right, so in the past, they tell us that carbon dioxide has changed due to changes in the climate, and it has been a result from several different factors, right? Okay, and they also tell us that this ice core data that we see right here is going to provide a record of atmospheric carbon dioxide measured from air trapped in the ice and parts per million, okay, and of the Antarctic surface temperature changes. So that's what we're looking at data from. And if we look at the data before we even go to the question, we can see that it's been fluctuating a lot over the years, right? So anytime that I see something increase, the other one also increase. So when the carbon dioxide increase, I can see an increase in the Antarctic temperature, and then as well as a decrease about the same time in each of them. So if you go through this data, you can pretty much see that they pretty much impact each other, right? So as the carbon dioxide increases, so does the atmospheric temperature, and as it decreases, so does the temperature. So now let's go to the question. It says, which claim correctly summarizes the data in the graph that a change to one Earth system causes a change to another Earth system? Well, we already seen what's happening, right? So let's go through our answer choices and see which one fits. So increasing atmospheric CO2 levels cause the Antarctic surface temperatures to decrease over time. Well, is that true? Did the temperatures decrease over time as we had increase in the atmospheric CO2? No, we didn't. Because if we have an increase in that CO2, we're also going to have an increase in temperatures. All right, number 2, variations in the atmospheric CO2 did not affect the surface temperatures. Well, we know that it did affect the surface temperature in some type of way, and I did not mean to circle number 1. I meant to cross it off. Okay, and then number 3 says, decreasing atmospheric CO2 levels cause Antarctic surface temperatures to also decrease over the same period of time. And yes, that is what we saw. Okay, so number 3 seems to be our answer, but then let's make sure number 4 is not our answer, which it says atmospheric CO2 levels stayed the same. Did they stay the same? No, they did not. We've seen a fluctuation taking place in both. All right, 15. So we want to use the rate of climate change that we just saw in the data to make an evidence-based forecast of how much Antarctic temperatures are predicted to change over the next 40,000 years, and describe the associated impact to one Earth system as a result of this change. So remember that the data said that the more CO2 we had, the higher the temps. The less the CO2, the lower the temps, correct? So if you go to your chart, and we're trying to see what happens in 40,000 years, right? So that's the last number. So if you go right here to the data, and they want a temperature, so we're reading the temperature only. So if we just make a little line to see our range, and so our range could be like a -10, and then maybe even to like the number 6, but actually, if I'm not mistaken, they give you a little bit more leeway than that. I think you can stop at about like -10 to 10. So if you don't want to just put one number for your answer, you could put -10 degrees Celsius through like maybe a -6 degrees Celsius, is that's what we see it stops at. Okay, and then so if we have temperatures that's going to go from -10 to a 6 degrees, we see that the temperatures have increased, right? Got a little warmer. So how does this associate with what we see happening in Antarctica? So think about it. We're talking about Antarctica ice, right? So if the temperatures increase, we can expect what? Our glaciers to decrease, right? Or our amount of ice that we have to decrease. So we could say something that like our glaciers will melt, right, in Antarctica. So glaciers will melt. And then what happens when glaciers melt? Our sea level normally rises when that happens, right? So we want to include that in our answer, causing sea levels to rise. What is one other thing that we could have also said for our answer choice was that, okay, so we have warming temperatures, right? If we have warming temperatures, we're also going to have probably warming oceans, right? So we'll have our ocean circulation that's also going to be impacted by association of rising temperatures, okay? All right, so that was it for number 15. Let's move on to 16. All right, so now we're on another cluster. So this is going to be from 16 to 20, this cluster, and it's all going to be based on the stars and the Big Bang Theory. And as you can see, questions number 11 through 15, we didn't need the reference table for, but this time we might need the reference table since we're talking about stars. All right, so it says our sun is 4.6 billion years old, and it's a yellow dwarf star. It was formed from matter producing during the Big Bang Theory, or from matter released from large stars reached during a supernova explosion. Okay, so this matter in the form of hydrogen contracted into a denser cloud due to gravity, right? And then it's increased the temperatures. And then we had the fusion of 2 hydrogen nuclei into 1 helium nuclei. And then the mass of this helium nucleus is less than the mass of the hydrogen nucleus. All right. This difference in mass is the source of the star's energy. All right, so that was a lot, but not too much. And then they give us this little diagram that's pretty similar to the one in our reference table. The only difference is that this one it just gives you a smaller breakdown, right? And it's in black and white, of course. Okay, so we can see that according to the diagram, that each star starts off at a different mass, and then it's going to depend on the mass with their life cycle, right? And we see that taking place. So my high mass stars only live for millions of years, medium billions of years, and then my low mass stars trillions of years later. This is what their life will turn out to be. So 16 says, identify the factor that determines the lifespan of the sun and other stars. Well, that was obvious, right? We just literally went through it in a diagram, and they told us as well in the paragraph that their life cycles or their lifespan is going to be dependent on their mass. All right, so mass, that's it. All right, so 17. 17 said the table below shows information about different types of stars. Solar mass is the mass of the star compared to the sun. Okay, so we see that this data chart has some information on it, and we're going to compare it to this data chart down here. It says a student created a data table containing information on how stars synthesize common elements through nucleosynthesis. Which row of data correctly identifies all of the characteristics of that star? So nucleosynthesis, we should know that's when our hydrogen and helium atoms fuse together to form different elements, right? Okay, so if we want to compare, we can look at, go row by row. Okay, that's your best bet. So row number 1 says it's the sun, and it went straight from hydrogen directly to helium, which we can see in our nucleosynthesis that they go from hydrogen to helium. And since the sun is a medium mass star, we know that the sun is a low mass star. Let me correct myself. So yes, we know that this might be correct. But also, it says 4.6 billion years lifespan. Is that true for our sun in our data chart at the top? No, it's only 9 billion. So that is what's going to make our answer wrong, okay? So since it's only 9 billion, we're going to mark off number 1. And then let's go to series B. So it goes directly from carbon, directly to oxygen. That could be possible, right? Series B is a main sequence star. And how do I know it's a main sequence star? Just can go to my star chart. Okay, so just like our sun, Sirius B is going to be main sequence. So it's not going to be high mass. So that's what's going to make that wrong. Okay, so even though the lifespan adds up to Sirius B as well as the nucleosynthesis, it's not going to be high mass. All right, let's go to Aldebaran. So Aldebaran is a giant star, right? Not a supergiant, but a regular giant. So Aldebaran, helium to carbon, all right? Medium mass, yes. 6.4 in life, yes. Okay, so everything for Aldebaran adds up. But if we just want to make sure that Wolf 39 wasn't our answer, we can go through it, and we already see Wolf 39 had a solar mass of 0.9, so it's not a high mass star. All right, so number 17 is 3, Aldebaran. 18. So we're using the information from the passage to check 3 boxes that identifies what accurately describes sunspots. So sunspots, okay? So if we learn anything in the school year, we know that our sunspots, they are basically darker spots on the sun, right? And basically they're going to have impacts of decreasing temperatures on certain places on the sun. And then also these things occur every 11 years. So honestly, you just need some background knowledge about sunspots. So if you have time in your day, look up sunspots, see what they are. All right, so then you go through process of elimination. What are sunspots, and what are my best 3 choices? So number 1, or the first option, says a decrease in the number of sunspots is inferred to the decrease in Earth's temperature. All right, so that is going to be one of my boxes, because if I don't have that many sunspots, that means I am also not going to have higher temperatures. The more sunspots I have, the higher the temperatures, because it tells us in the paragraph, where in the paragraph did it tell us? All right, okay, maybe they didn't tell us in the paragraph, but okay, so I'm just letting you know now, those sunspots, as we get more sunspots, we get higher temperatures, okay? So then, or it's actually going to depend on where the sunspot is taking place on the sun. Okay, so then the number of sunspots occurs every 11 years, yes. An increase in solar output is associated with a decrease in the number of sunspots. An increase in solar output is not going to be associated with it. And then the average number of sunspots appearing each year has decreased since 1950. And we don't see a decrease since 1950. We see that it actually just fluctuate up and down, increase and decrease. So we're not going to pick that one either. The last one says sunspots are regions of cooler temperatures on the surface of the sun. So these are on the surface of the sun, not the surface of the earth, correct? So if that's the case, then yes, this is going to be another one of our options. Okay, and so I'm not really good with sunspots. I'm not even going to go through it anymore. Like I said, it's always best to familiarize yourself with enough information before you take these exams. All right, number 19. Why can't I get this paper apart quick enough? Here we go. All right, so this is the front of 19, okay? It says that our scientist Edwin Hubble studied the motion of galaxies, and he found the relationship between a galaxy's velocity as measured from Earth, recessional velocity, and the galaxy's distance from Earth, and said that this relationship is known as Hubble's law. This law has implications for understanding how the universe has changed since the Big Bang. So recessional velocity is basically how fast or how slow something is moving away from, right? Receding away. So as we can see, the closer the galaxy is to Earth, the faster it moves away, but then the further it is from Earth, the slower it moves away. So let's flip it over. Now, what they want us to do in this question is fill in the blanks. So we want to fill in a blank. Of course, we read what they said in the beginning, and we must have knowledge of the Big Bang Theory and what took place. So let's read through it. So the relationship between galaxies' distance from Earth and recessional velocity graph shows that the recessional velocity of a galaxy, as a galaxy's distance from Earth increases. Well, what did we say in the beginning? Right? It increases. Right? It goes faster. So it increases proportionately, which is going to be either choice 1 or 3. Okay, then next, let's go to the next fill in the blank. It says, this is evidence for the blank of the universe. So expansion is B for both. Okay, so then let's go to the next. And suggests that the universe initially was blank at the time of the Big Bang. So was it inflated or was it compacted? Well, we're not sure, which I am sure. I know which one it is, but I just want to see how you can go about this question, okay? So if you're not sure, read the last sentence and see if it has been accelerated or decreasing. So it says, as a result, this data suggests that the universe is changing at a blank rate. So is it at a decreasing rate or at an accelerating rate? Well, think about it. Things are moving, increasing proportionately. That means moving fast away. Then that means it's probably going to be moving at an accelerated rate, right? So just make sense of it for yourself, okay? That's the best thing to do. 20. Particles were created as a result of the Big Bang. The first particles were subatomic particles like protons, neutrons, and nuclei, lighter elements such as hydrogen, helium, lithium, and beryllium. All right, and so this is a graph. They're showing us what happens seconds after the Big Bang, hundreds of seconds after the Big Bang, thousands of seconds. Okay, so what happened? And we see a temperature increase and a decrease. So based on the graph or the information that we see, which answer choice best reflects what happened minutes and seconds after the Big Bang? So it told us in number 1, yes, this is a process of elimination question. That's the best way to go about it, okay? So they told us in number 1 that from 10 to 100 seconds that we had hydrogen and helium decrease, and the temperatures increase then decrease. So did that happen from 10 to 100 seconds? So yes, they increased, right? Yes, they did increase. But what happened? It said that they decreased, right? So no. But the temperature increased and decreased. So the temperature was correct, but the particle present was not. Okay, let's try it again for number 2. So 100 to 1,000 seconds after the Big Bang. So from here to here, it said that hydrogen increased and helium and then decreased. So let's see, hydrogen increased and then it went down, decreased. So yes. And then it said, while helium increased and remained constant. So let's go to helium. Here we go. and increase, and then yes, remain constant. That is correct. That's exactly what it does in the chart. And so what about the temperature? Yes, it goes from 3 times 10 to 1 times 10. So number 2 seems to be our best choice. And then as well, if you want to make sure that the rest of them is not correct, you can always go through them for yourself. All right, so that was the end of that cluster. We will be starting another cluster. All right, so this is number 21 through 25. And we're going to be talking about the Hudson River. So it says, the Hudson River's, New York Hudson River watershed covers almost 1,340 square miles. This is what happens when you try to talk fast. And then also, I'm not going to even read through all of this, okay? So the Hudson River flows south from the Adirondacks. And then the most important part, it says, here, fresh water flowing south down the river meets salt water pushing in from the Atlantic Ocean. Okay? So that's all I'm going to underline, and just understand that these are going to impact the salt fronts and drinking water, quality of drinking water. So it says, number 21, describe how heavy rain events along the Hudson River would affect the location of the salt front. So they put the diagram that will help you look at this a little bit more clearer, a salt front, all the way on page 27. So we can see the salt front right here. And then here's the tidal estuary where all the water lets off. And here's the Atlantic Ocean. Okay, so what if we have heavy rain? What is going to happen to the salt front? It told us that the salt front pushes in from the Atlantic, right? So the more heavy rain you have, you could say something like, the more heavy rain that we see, or you could say as rain increases, okay? So more heavy rain, or as rain increases, the salt front will be pushed closer to the Atlantic Ocean. Now, Atlantic, I can't spell right now, Atlantic Ocean. Okay, so now what I see when I was grading these exams is that a lot of people was able to say this, right? They were able to say that the salt front was going to be moved because of the heavy rains, right, and the tidal waves. But what they failed to say was that it was going to be pushed closer to the Atlantic Ocean. So don't forget to mention where these things are moving so you can get the answer correct, okay? So it's going to move closer to the Atlantic Ocean. All right, 22. All right, so they said that the salinity is measured in milligrams of chloride. Yes, I skipped over some. Don't skip over anything. You always read everything, okay? All right, so where is the salinity if they told us that the salinity is 100 grams, 100 mg/L? This is where we find the salt front. So they said a student made a claim that the location of the salt front is consistently changing due to the weather conditions, which we know this. So which table correctly identifies where we found the salt front on October 6th through October 12th? Well, didn't it tell us that the salt front is found between 100 mg? All right, so all you have to do is see what two numbers fit between 100 mg on both your charts. So on the first chart, between 350 will sit 100, right? And then on the second chart, between Cold Spring and Verplank will sit 100, right? So that is your answer. So which answer choice tells me that between Paramount and Bearmount, and then Verplank and Cold Spring? So answer choice number 2. All right, 23. All right, so they give us this more information about this advancing salt front because we know that this is a health hazard to our water. So now it tells us that they made a budget plan. This plan is $400,000, a $400,000 budget plan, okay, for the next 35 years. They allocate $25,000 to predict the salt front location. They allocate $150,000 to develop the proactive action. Based on the evidence in the plan developed by the environmental groups, which explanation correctly describes how availability of fresh water will influence communities along the Hudson River? So, process of elimination. Okay, just go right to process of elimination. So cities along the Hudson River will spend considerable amounts to find alternative drinking water sources as salinity decreases over the next 50 years. No, they said they will evaluate it over the next 35 years, not 50 years, okay? Cities along the Hudson River will spend $400,000 to monitor the salt for over the next 50 years. Okay, so for number one, actually, what made number one wrong is because they said as the salt decreases. So if the salt is decreasing or the salinity is decreasing, then we will not need to do anything. Okay, number two, what makes that wrong is because they said they were going to spend the $400,000 over the next 50 years, and we know that they said it was 35 years in the text. Okay, then number three says communities that use the Hudson River for drinking water will spend $400,000 to monitor salinity and develop plans to purify water if necessary at water treatments. Yes, that is correct, because that is what they said they were going to do throughout the whole plan. Okay, and then also you want to check number four, communities that have used the Hudson River for drinking water will spend $150,000 to predict. Did they say they would spend $150,000 to predict? No, they said they would spend $250,000 to predict. All right, so the best answer choice is number three. All right, so now we are on number 24, EPA. All right, I don't think we need that picture on the front, so I'm going to skip over that one. So we are going to base our answer on this graph right here. It says, based on the model and a graph, which is the best logical solution that will cause the greatest decrease in PCB levels in the Hudson River? So we're trying to decrease those PCB levels, but they told us that at some point they told us that they had dredged, right? And they said that dredging, they had dredged in the past, and that it had removed some of the contaminated sediment. So they dredged between 2009 and 2015. And they told us that this is their target if they dredge again. So they want to be at 0.4 if they dredge, and then 0.2 after 16 years after dredging. So it says, based on the models, which could be the next logical solution that would cause the greatest decrease in PCB levels? Of course, not number one, because we don't want to do nothing, right? Number two said dredge additional areas that still have PCBs and sediment to permanently remove the pollutants. Well, yes, that could be possible. Why wouldn't we want to dredge more, right? Dredge more. Or number three says building another dam where the dam was removed. Well, in the paragraph, they told you that when they removed the dam, they found toxics, right? Things that were toxic to humans. So we don't want another dam, because if that's the case, we're going to have more toxicity happening, right? Okay, so number four says breed larger fish. If we breed larger fish, they're going to take in more PCBs. They're going to spread around more PCBs. We don't want to breed larger fish. So the best thing we want to do is we want to dredge some more. Okay, so after we dredge some more, it says explain how the graph supports the claim that dredging the Hudson River has only been partially effective at reducing the PCB levels compared to the EPA targets. Well, it told us that the target was in 5 years 0.4, but in 2020 it's at 0.63. So the target was not reached, right? So we could say that the PCB levels as of let's see, 2021 have not met the targets. Okay, for 2020, because in 2020 we know we wanted to be at 0.4, but we're not there, right, for 2020 or 2021. Or you could have said something like PCB levels in the fish did not decrease and the EPA targets were not met. Okay, so we didn't reach them according to the data. All right, so that is it for clusters 11 through 25, and this is cluster 26 through